Every object that travels through our solar system has a story. A story written in the language of physics, a tale of its journey told by its speed, its direction, and its path across the sky. For asteroids and comets born within our own system, this story is a familiar one, an elliptical loop returning them again and again to the Sun. But 3I/Atlas tells a different kind of story. It is a story with a beginning we cannot find. When astronomers first calculated its trajectory, they immediately saw the telltale sign of an outsider, a wide, open-ended hyperbolic path. This was not an object caught in our Sun's gravity. This was a tourist merely passing through, a visitor from the vast darkness between the stars. The next logical step in any investigation is to trace that path backward. To rewind the cosmic clock, following the comet's trail out of our solar system, past the Kuiper belt, beyond the Oort cloud, and into the galaxy to find its home. But this is where the story breaks down, and a cosmic crime scene reveals its central mystery. When we trace the trajectory of 3I/Atlas backward through space and time, it doesn't point to any known star. It doesn't align with any nearby stellar nursery or planetary system. Its trail leads to a seemingly empty, unremarkable patch of the void. This is, to put it mildly, a problem. Comets are not born in a frozen emptiness between stars. They are the leftover debris from the formation of stars and planets, born in swirling protoplanetary disks and cast out to live in immense reservoirs like the Oort cloud. They meet a parent star. For 3I/Atlas to come from nowhere is an impossibility. Furthermore, its incredible velocity suggests it wasn't just nudged out of its home, it was violently ejected, flung with a force that sent it careening across the galaxy. So we are left with a cosmic paradox, a body that must have a home, but whose trail leads to nothing, and a velocity that suggests a violent departure, but with no visible perpetrator. This is the mystery of its impossible origin, a cold case that forces us to look beyond the usual suspects and investigate the most extreme and violent events the cosmos has to offer. Our investigation begins with the most plausible, yet deeply somber, suspect, that 3I/Atlas is a rogue wanderer, a refugee cast out from a dying star system. The life and death of a star is the most powerful engine of change in any solar system. For billions of years, a star like our Sun provides stability, its gravity holding its family of planets and comets in orderly orbits. But as the star exhausts its fuel, it swells into a red giant, a colossal, fiery behemoth that engulfs and incinerates its inner planets. After this phase, its core collapses into a white dwarf, a small, hyperdense stellar remnant. While the inner system is a scorched wasteland, the outer system, including its own version of the Oort cloud, may survive. However, the gravitational balance is shattered forever. The star has lost a significant portion of its mass, and its gravitational grip on the surviving outer planets and comets is weakened. What follows is an age of chaos. The surviving gas giants, no longer held in their steady orbits, begin to migrate and drift, their immense gravity acting like a cosmic slingshot. They careen to the system's outer comet cloud, their gravitational influence flinging countless icy bodies into new, wild trajectories. Most are sent into the white dwarf to be consumed, but many are ejected with tremendous force, cast out of their home system forever to wander the galaxy as interstellar orphans. This scenario elegantly explains two of our key clues. It provides a source for the immense energy required to give 3I/Atlas its high velocity. The gravitational assist from a Jupiter-sized planet is more than enough to create a powerful cosmic fastball. It also explains why its trail leads to nowhere. This event would have happened millions, perhaps billions, of years ago. Since then, the dead star system and the ejected comet have been moving independently through the galaxy, their paths diverging as the galaxy itself rotates. After such an immense passage of time, tracing the comet's path back to its specific, long-dead parent star is a near-impossible feat of celestial forensics. 3I/Atlas, in this scenario, is a ghost, a messenger from a solar system that has long since perished. If the death of a single star system is not a grand enough crime, then we must consider a suspect of an even greater magnitude, a galactic collision. On the scale of the Milky Way, star systems are not isolated islands. They are in constant motion, orbiting the galactic core. Occasionally, especially in dense, star-forming regions of the galaxy, two star systems can pass dangerously close to one another. When this happens, the results are catastrophic and spectacular. The two systems don't physically collide, but their immense gravitational fields interact in a destructive tidal dance. As they pass, they can rip entire planets and vast swathes of comets from each other's grasp in an act of galactic piracy. The Oort clouds of both systems would be completely disrupted, their contents either stolen by the passing star or flung out into deep space like shrapnel from an explosion. Free I/Atlas could be an orphan of one such cataclysmic encounter. It would have been born in a normal, stable solar system, only to be violently torn from its home by the gravity of a passing star. The energy imparted during such a close flyby would be enormous, easily accounting for the comet's high speed and bizarre trajectory. This theory is compelling because we know these events happen. Astronomers can identify clusters of stars that are moving together through the galaxy, which are often the remnants of past interactions or shared birth clouds. In theory, we could attempt to match the trajectory of Free I/Atlas to the historical path of one of these stellar groups, searching for a cosmic hit-and-run that occurred at the right time and place. However, the challenges are immense. The galaxy is a swirling, chaotic environment. Over millions of years, the stars from these encounters disperse, and their paths become muddled. Finding the specific stellar encounter that cast Free I/Atlas out into the void is like trying to find two specific cars that scraped past each other in a city with no traffic cameras, decades after the event. The comet would be a lost child, its parent systems having long since vanished into the galactic crowd. Our first two suspects, while dramatic, operate within the known rules of how star systems live and die. But what if Free I/Atlas comes from a place far more extreme, a place where the rules of creation are entirely different? Our third suspect takes us to the most violent and exotic location in our galaxy, the accretion disk surrounding the supermassive black hole at its heart, Sagittarius A star. This is a place that defies conventional imagination. It is a swirling vortex of gas, dust, and shredded stars, all being pulled into the maw of a black hole with the mass of 4 million suns. For decades, we considered such an environment to be a forbidden zone for the formation of anything stable. The intense radiation and brutal tidal forces, which can stretch an object like spaghetti, should make it impossible for small dust grains to gently clump together to form planets or comets. However, recent theories are challenging this assumption. Within the turbulent, but incredibly dense, gas cloud of the accretion disk, it may be possible for icy bodies to form rapidly. The sheer density of material could allow gravity to overcome the violent forces, creating impossible objects in the black hole's shadow. This would be a factory for monster comets, born not from the gentle beginnings of a solar nebula, but forged in the heart of galactic chaos. This theory provides the most elegant explanation for the comet's incredible speed. Being born so close to a supermassive black hole, it would only take a tiny gravitational nudge, perhaps from a passing star or another dense clump in the disk, to fling the newly formed comet out of the galactic center with almost unbelievable velocity. It would be launched like a stone from a sling of unimaginable power. This would perfectly explain why its trajectory appears to come from nowhere. After exploring the crime scene and interviewing our three prime suspects, we are left without a definitive culprit. The trail is too cold, the cosmic timeline too vast. Was Free I/Atlas a refugee from a dead star system, an orphan of a galactic collision, or an impossible child of the supermassive black hole at our galaxy's core? We may never know for certain. But the true significance of this investigation is not in finding a single, neat answer. The importance of free I/Atlas lies in the questions it forces us to ask. Its impossible origin shatters our simplistic models of the universe. It proves that the cosmos is not just a collection of orderly, stable solar systems like our own. It is a place of incredible violence, chaos, and, most importantly, creation in the most extreme environments we can imagine. Free I/Atlas is a physical piece of evidence, delivered directly to our doorstep, from one of these unknown realms. It might be a fragment of a solar system that died before our own was even born. It could be a relic from a time when our galactic neighborhood was